Welcome to Pomodoro Joe for Monday, October 2nd, 2023. Today we're looking at LeetCode problem 2038. Remove colored pieces if both neighbors are the same color. This is a medium problem. Wow, I'm not going to read this whole thing. All right, so essentially what this one is, we're given a list of colors, an array of colors called colors. Now, the colors can only be two types, color A or color B. Now, this is a game. You have two players, Alice and Bob. Alice is allowed to remove colors of color A. Bob is allowed to remove colors of color B. But the restrictions are, you can only remove a color element if both of its neighbors are the same color. So in this example here, we have three A's, a B, an A, and two more B's. In this case, you can remove this center A of these three A's, but none of the other colors could be removed because there are no other colors where both neighbors are the same color. So this A has to be surrounded by two other A's. This A having two neighbors of color B doesn't count. All right, now in this game, Alice goes first, then Bob goes second, and they alternate turns until one of them runs out of turns. One of them can't make a move. Now the player that can't make a move loses. So Alice starts. As soon as one of them can't make a move, that person loses. Our goal is to return true if Alice wins, or return false if Bob wins, assuming both players are playing optimally. That means they're both making the best moves that they can make. Okay, so let's put 25 minutes on our Pomodoro timer, and we will get started. All right, so for this one, the first thing to do is take a look at these examples. So we have three A's, a B, an A, and two B's. Now, in this case, the only thing we can remove is this one A. So that kind of is a sign here. What can we remove? We can only remove things that have the same color on either side. So you have to have a group of at least three, because you have to have one color on either side that's the same, and then the one color in the middle that you can remove. So you could have longer strings, so you could have 4, 5, 6, or 7, as many as you need to, but you have to have at least two. That's one for either neighbor. The other thing to notice is because you have to have at least two, that means when you do have two, you can't remove one of them, you can't remove both of them, so those two are kind of like these immovable pieces. This means that if you've got something like, let's see, A, B, 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 A, whatever it happens to be, you might be able to remove some of these B's, but you'll never be able to remove all of these B's. So you can get it down to A, B, B, A, but you can't remove any more B's. That shows us you can never actually merge or combine. How do I put this? Once you have a separation of colors, like this A and this A, you can never remove the separator color in between. So you can never merge two sets of independent colors. Now, that being the case, that means that we don't actually have to play this game. So all we really have to do is just go through all the colors, counting these sort of islands of colors. Anything that has two or fewer of the same colors, we can just throw away. We're never going to be able to remove any color from that. If we have three or more colors, then we can remove some colors from that, but we can't remove all the colors. We can remove essentially the color count minus 2. That's minus the ones on either end. So then we just add up how many of these turns or how many of these removable colors we have. That tells us how many turns each player has, and then we just return whether or not Alice has more turns than Bob. Now, is it more than or equal to? Well, since Alice goes first, Alice gets one turn, then Bob gets one turn, then Alice gets her second turn. So basically, Alice always has to have one more turn than Bob. If they both just had one turn, then Bob will win. So Alice always has to have greater number of turns than Bob. All right, so let's get started. So let's start by keeping track of the turns. So we'll have Alice turn count. I'll just call it Alice turns, and we'll set it equal to 0. Then we'll have Bob's turns. We'll set that equal to 0. All right, and now we'll go through all the colors. So for every color in colors, all right, if this color is the same as our current run of colors, let's kind of keep track of what's our current color. So if this color is equal to our current color, well, then we can add one to our current color count. So essentially, I'm just going through, I'm going to keep track of how many of any particular color I have in a row. So that means I'll need this current color, And then I'll need our current color count. All right, so let's grab these variables and we'll define them out here. So my current color, well, we don't start with any colors, so I'm going to set it to none. And my current color count, we don't start with any colors, so I'll set it to 0. All right, so we'll go through. If our color that we find here is the same as our current color, then we can just add 1 to our count. That's how many of these colors we found in a row. And I guess at that point we can just continue. So I'll just say continue. All right, if this color is not the same as our current color count, how do we handle this one? Well, at this point we know we've transitioned to a new color. So if our current color count is less than 2, or less than 3 in fact, that means that this grouping, this sort of island of colors, had fewer than 3 colors, which means we couldn't have removed anything anyway. It's kind of a no-op in this case. It doesn't really count for anything. So if our current color count is less than 3, that means we only had 2 colors or fewer, then we can't really do anything with these colors. We'll just continue. Well, that's not true. We need to update our colors here. So our new color, or our current color, becomes this color, and our current color count gets reset to 0, it gets reset to 1, because we do have this 1 of this new color. All right, and then we'll continue. So I could do this, continue, or I could actually check, do the opposite. If this is greater than 2, then we'll score these points, and then we'll always reset our color, and we don't need this continue. All right, I like this better. All right, so if we have the same color as the current color, we'll just add 1 to our count and we'll move on. If this is not the same color that we have currently checked, then we'll have to update our color to this color, and we'll have to reset our count to 1. So this is the start of a new run of the next color. All right, now, if that is the case, we just had a run of colors, we're starting a new run of the next color. Let's check here. Did we have more than 2? If we do, then somebody's going to get to score some points, or move, actually it's not score points. That's going to give somebody some set of turns. So let's see here. Our turns will actually be our current color count minus 2, because we can only remove the colors in the middle. The colors on either end don't count. So for example, if we had a run of 5 of the color A, we can't remove the ones on either end, but we could remove those 3 in the middle. So that's 5 minus 2, that gives us 3. Okay, and then who gets these turns? Well, if the color was A, Alice gets the turns. If the color was B, then Bob gets the turns. So if the current color is equal to A, then these are Alice's turns. So Alice turns gets increased by this turn count. Otherwise, Bob gets them. And now at the very end, we just have to return, did Alice have more turns than Bob? So we can return Alice turns greater than Bob turns. Okay, so I think this should do it. Let's just take a quick look. We'll keep track of how many turns Alice and Bob get. Then we'll keep track of our current color, what's the run of our current color, and how many there are. Then we'll go through every color in our colors array. If the color is the same as the current color, we're continuing our run. So we just increase our current color count by 1 and we move on, we continue. If this isn't the same color, then we've ended a streak of colors or starting a new streak of colors. Let's check the current streak. Is this current color count greater than 2? That means we had some turns in there that we could remove colors from. So our turns will be the current color count minus 2, because we can't use the ones on either end. And then who gets those turns? Well, if the current color was A, this run was Alice's color, then Alice gets those turns. Otherwise, Bob gets the turns. And since we're starting a new streak of this color, this new color, our current color gets switched to this new color, and we restart our current count at 1 because this first color does count. Okay, let's try this. Okay, it seems to work. Let's submit that. And we get a wrong answer. Let's see, we return true when it should have been false. That means we're giving Alice more turns than she should have. Let's see here. Oh, what we did wrong. I think what we did wrong. At the very end, so we made it through all the colors, we might have a run that we didn't score because we didn't get to this switch. I think that's the problem. So we need to score this last run, and it's basically this thing here, if the current color count, so on and so forth. All right, let's do that. Okay, so that should do it. Let's hope. Oh, let's see. All right, let's see if that works. There we go. That seems to work. Actually, I didn't use that test case. I think I remember it though. Let's see if we can just add it in. Test case, we'll add a new one. I think it was 4 A's and 4 B's. Okay, there we go. Let's try this. And now we pass. All right, let's see how we did. We did okay. Whoa, actually no, we did more than okay. Holy smokes, what? We beat 97% for runtime and 65% for memory. Wow. I was not expecting that. That is like way better than I thought. Okay, so this is a pretty decent solution actually. We'll just go through, count all the colors, figure out who gets the turns for those colors, and then we just return whether or not Alice had more turns than Bob. Sweet. All right, well, I think that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.